Assalamualaikum and greetings to all. Today's topic is on a domain of multivariable functions. So we're going to look at functions of two variables and also functions with three variables. Okay, let's start with functions of two variables. Okay, let's say here we're given z, z equals f of xy. Okay, so in this case, x and y are the independent variables and z is the dependent variable. Okay, now let's look at our function f. So this is the definition. A function f of two real variables x and y is a rule. So it says here it's a rule that assigns a unique real number fxy to each point xy in some set D of the xy plane. Okay, now let's say here we have the xy plane. And here we have a point xy. So when you put this point xy in function f, you will end up with a unique value z. Well, it says fxy, but then fxy is, in this case, it's z. So you have a unique value z when you put point xy in function f. So f here is a rule. Okay, now similarly you can do that in functions with three variables as well. So here it says the definition. A function f of three variables x, y, and z is, again you can see rule here, is a rule that assigns a unique real number f(x, y, z) to each point x, y, z in some set D of three-dimensional space. Okay, now, so let's say here you have a function w is equal to f x, y, z. So here you can see that x, y, z are what we call the independent variable. And here w is the dependent variable. Okay, now according to the definition of function f, it's a rule. So let's say you have a point in three-dimensional space. The point is x, y, z. So here we have three-dimensional space, y-axis, x-axis, and z-axis. So here we have a point x, y, z. So when you put this point x, y, z in a function f, it will give you a unique value w. Okay, so in this case, all possible values of the points x, y, z is what we call the domain, and all possible values of w is what we call range. Okay, same thing with function with two independent variables. Okay, so here all possible points of x, y, so set of x, y is what we call the domain, and all possible values of z here is what we call range. Okay, now let's look at the definition. So back to your notes. Okay, all right, now let's look at the domain. The domain of a function is a set of points, okay, at which the function is defined. So here on the xy plane we have many points xy. So set of points xy that can make the function defined is what we call the domain. Okay, and the range would be all possible values of z. Okay, and similarly for function of three variables, okay, set of points x, y, z where the function is defined is what we call the domain, and set of value w is what we call the range. Okay, now let's look at some examples. Okay, back to example 1.1, which is in chapter 1. Okay, if you refer to your notes, all right, example 1.1. Okay, so here we're given a function, so I'm going to call this z. z fxy. So the function fxy is given specifically as 3x squared square of y minus 1. So it has two parts. The first part is we need to find the value of f at 0.14. Okay, so in this case we want to find the value of z when x is 1 and y is 4. So it's very easy. So what you do is you replace x in the function f with the value 1, and when you see y you replace it with 4. So this will give us 3 1 squared square of 4 minus 1, and when you evaluate this you get 3 times 2 minus 1, which is 5. So you can see here at 0.14 we have a unique value 5. Okay, so that is the value of the function at 0.14. And we can do the same thing for another point, which is at 0.9. That's an ugly 0. Okay, so for the value of f or the value of z, we can say the value of z, or you can say the value of f at 0.09. So what you do is you replace x with 0 and y with 9. So we have 3 times 0 times square of 9 minus 1, so that will give us negative 1. Okay, so what it says here is at 0.09, you can say z, you can say f, okay, is equal to negative 1. So it has a unique value. Alright, now that's easy peasy. Okay, now let's look at the second part of the question, which is finding the domain of f. So remember, the domain would be set of points. So in this case, our points consist of x coordinate and y coordinate. Okay, so now we want to find the domain. So the domain is going to be set of points. So if it's a set, you're going to write it in between the two curly brackets. So our set is going to be set of points. So set of points meaning it has x coordinate and y coordinate, because here we're dealing with a function of two variables, x and y. Okay, and then we have this line here such that, okay, so now we have to think of constraint or the restriction for x and y. Is there any restriction on x and y so that the function is defined? Okay, so here we have our function 3x squared square of y minus 1. So x occur at here. Okay, we have x squared. So from previous class, we know that you can square any real number. So there's no restriction on x here. So x can be any real number because you can square any real number. But here, now let's look at the constraint for y. Is there any constraint for y? So y occur here. We have a square root of y. So we know from before, if you have a square root of y, meaning that for the function to be defined, y must be larger than or equal to 0. Otherwise, you'll end up with a complex number instead of a real number. So there is a constraint for y. Y must be larger than or equal to 0. So this is the domain. So set of points x, y, where y must be larger than or equal to 0, but x can be any real number. Okay, now I'm going to explain a little further. Instead of just finding the value and also the domain, I'm going to add one more, which is let's sketch the domain of the function. Okay, so we're going to sketch the domain of the function. So remember from before, the domain of the function here would be, oh, this is 3D, hang on, okay, this is 3D. Alright, so the domain would be set of points x, y. Okay, set of points x, y. That would be the domain of function fxy. So back to our example here. Okay, so our domain would be set of points x, y, where x can be any real number and y must be larger than or equal to 0. So our point would be on a xy plane. okay, because it's in 2D. Right, so let's say here we have, oops, hang on. Right, so here we have the y-axis and here we have the x-axis. Okay, here we have x-axis and y-axis. Okay, now when you look at the values for y, constraint for y, it says here y can be any real number. So, sorry, x, when you look for the constraint of x, x can be any real number, meaning that x can be in the first quadrant, second quadrant, third quadrant, and also fourth quadrant, and also on the axis. So no constraint there. But then here we have y must be larger than or equal to 0. Okay, so y larger than or equal to 0 occur, well, y0 would be on the x-axis. Okay, any point there, and then it must be larger. So any points in the first and the second quadrant and also on the x-axis would be the domain of the function. Okay, so the domain of the function would be any points in the first and the second quadrant and also all the points on the x-axis. So this is the domain of the function. Okay, that is example 1.1, which is this. Okay, all right, so we have we look for the values at 2 points, 1, 4, 0, 9, and we also determine the domain of the function. And one step further, we also sketch the domain of the function, where we have the area where the points will make the function defined. If any point here in the third quadrant or the fourth quadrant, then the function won't be defined, because here the value of y is negative and here the value of y is also negative, but we cannot take the value of square root of a negative value. Okay, all right, well, it doesn't say ask for the range, so for the second part, instead of one more part, for example 1.1, let's also get the range of the function. So this is third, and the fourth is finding the range. Okay, all right, so this is 1a, this one is b, all right, now we want c, which is finding the range. This one is b. Okay, for range, remember for range, we look for all possible values of z. That would be range, all possible values of z. Okay, in our example, the function is z equals 3x squared square of y minus 1. Okay, all right, now we want to know the range. So the range would be set of all possible values of z. Okay, all right, or you can put f if you like, but I'm going to use z. Okay, so now ask yourself, what are the possible values of z? Okay, so here we have, let's start with 3x squared. Let's say z is 3x squared. Okay, we know that x squared will give you a positive value, multiply with 3, so that will give you a positive value. Okay, now let's say your function is 3x squared times the square root of y. So here we're using the positive root. So again, we have a positive value 3 times x squared, which is also positive, times the positive root of y. So that will also give you a positive value. Okay, but our function is 3x squared square root of y minus 1. Okay, so at first we have 3x squared y, that square root of y, that will be larger than or equal to 0. So this will give us, we know straight away that it must be larger than negative 1. Okay, I'm gonna rewrite this if that you might have confusion there. Okay, let's say I'm rewriting this as this. Okay, So if I have negative 1 plus 3x squared times square root of y, so we have negative 1 plus, and this value here are always positive, which means that this will always be larger than or equal to negative 1. So that would be the range. Okay, so the range, z must be larger than or equal to negative 1. I hope that makes sense. All right. Okay, how are we doing with time? Oh, 15 minutes. I'm going to stop. Thank you.